let's consider this next example. I've got f of x, which is ax cubed. I've got bx squared plus cx plus d. All four variables are unknown, and we have to find the value of each of those variables given that. Now let's just start making sure we understand exactly what we've got. F of 1, we've been told, is equal to 0. F of 2, I've been told, is equal to 0. And the derivative of f where x is equal to 0 is equal to 0. So what does that actually mean? All right, what that means is that where x is 1, y is 0. That's an x-intercept. Where x is 2, y is 0. It's another x-intercept. Where the derivative of f is equal to 0, the x is 0. Well, what does that mean? That's your turning point. Okay, and where your turning point is, we know that the x coordinate is going to be 0. So I know the x is 0. I don't know what the y coordinate is though. Okay, and then finally I've been told that where x is 0, y is -4, and what that is your y-intercept. Okay, now if you've got a cubic function, do you remember that your constant term, the one at the end over there, always represents your y-intercept? So in fact, without any working out, I already know that d is 4, okay, -4, all right? So let's substitute that in. So we're going to say I've got y is equal to, we've got ax cubed plus bx squared plus cx -4, all right? And now we've got to start the process of finding the other variables. And I think the best place to start is let's work with the fact that we have this turning point, okay? We know that turning point automatically requires us to take derivative equal to 0, okay? So I need to make the derivative of your function equal 0. What is the derivative? We have got 3ax squared plus 2bx plus c, and we're making it equal to 0. What is the x coordinate at the turning point? The x coordinate at your turning point was 0, so we can use that. So I'm going to substitute 0 into these x's over here. All right, and that leaves me with c. And pretty much that boils down to the fact that c equals 0. Okay, everything else lands up being 0, so that's it. All right, excellent. So we can plug that in there because we now know that c is 0. So we have got y is equal to ax cubed plus bx squared. 0 as a c value pretty much then eliminates that term. Okay, we don't write anything in that term, so then we're just sitting with a -4 over there. Okay, so let's see. We've used that as its y-intercept. We've used this as the turning point. So it's these two coordinates over here that we haven't actually used yet, and that's what we need to do next. Okay, so those 2 points are now 2 other points sitting on your line. So the idea here now, guys, is that to find the value of A and find the value of B, we're going to have to do a simultaneous equation. And I'm going to do it by first substituting 1 and 0, and then by substituting -2 and 0. So the y is 0, and into all of the x's, no, we don't want that, into all of the x's, we're going to substitute 1. All right. And that's giving me b times by 1 squared -4. All right, that simplifies down, if I just get it nice and simple, into an equation of 4 equals a plus b. And just like we do with the simultaneous equation, I'm going to call that equation 1, okay? Now I'm going to substitute in the -2 and 0. All right, same story. We've got y equals, instead of all the x's, we're substituting -2's. All right, that's going to be squared -4. And what does that simplify to? Okay, I'm just going to save all the working out. We land up sitting with a 1 plus 2a equals b. That's equation 2. All right. So what have I done? I substituted those two other points that we had into the x's and the y's of the equation. The reason is that I'm trying to create a simultaneous equation, which I've done, okay? Because we've got equation 1 and we've got equation 2, all right? Now, in equation 2, if b is the subject, if I've got b as the subject of equation 2, what I'm going to basically do is say, substitute equation 2 into equation 1, all right? What does that mean? Everywhere you've got a b in equation 1, we are going to replace it with 1 plus 2a. So 4 equals a plus, and instead of the b, we're going to replace it with the 1 plus 2a. That is then going to work out as 1 as my value for a. And once we know what a is, we can sub that back into either equation 1 or equation 2. It really doesn't matter. I'm going to sub it back into equation 1. So instead of the a, I'm replacing it with a 1 plus b, and that gives me 3 as my value for b. Okay, so what was the final equation? So we had a, which was, sorry, let's go back for a second. A, which is 1. So we've got y equals 1x cubed plus 3x squared. C was a 0, so it fell away, and we had minus 4. Okay, so you really used all of that information that they gave you in the beginning. We used the y-intercept because we straight away knew that was the d. We used the turning point by letting the derivative equal to 0. And we used the other 2 points as just points on your line, which we substituted into the equation, and we did a simultaneous equation with that. There we go. Well done. I hope you understood all of that, and we'll see you next time.